Hello, good morning, and good afternoon. Thank you for joining us for today's presentation. Today, we're going to be chatting with Cameron over at Pill Club. We're going to be focusing on two different elements. For the start of this presentation, we're going to be looking at a couple of use cases that Cameron is putting into play over at Pill Club on how he and his team is securing their dev environments. And then we're going to shift over to a fireside chat, which will be co-hosted by our CPO and co-founder, Alex. Before we get started, let's introduce our guest speaker today, Cameron Seebach. He is the Senior DevOps Engineer and Team Lead over at Pill Club. As the DevOps engineer, Cameron was the first to identify opportunities for expanded use of cloud computing services across the Pill Club. He has led the implementation of systems that handle millions of SMS messages monthly and leverage Elasticsearch to optimize operation workflows. Passionate about all things AWS, Cameron builds solutions that meet the scaling challenges, strict security needs, and compliance goals of a hyper-growth healthcare business. He composes electronic music under the name of Ham Sandwich Quantum Party and holds a BA in computer science from Cornell College in Mount Vernon, Iowa. With that said, Cameron, I'm going to hand this off to you.
Hey, everybody. My name is Cameron Seebach. I'm a senior DevOps engineer and tech lead at the Pill Club. A little bit about me. I've been in the space for about maybe 7 or 8 years combined across roles in IT administration, application development, and now DevOps. I started my career in IT admin and then very quickly realized that I did not want to be plugging and unplugging printers for the rest of my life. And so I went back to school, got a degree in CS, and through some ups and downs, now I'm here to talk to you about some cool stuff that we're doing at the Pill Club regarding dev environments. Next slide, please, Elliot. And a little bit more about the Pill Club. We are a digital health company. We empower women to lead their healthiest lives. We're the easiest way for them to get access to sexual health and wellness resources. We serve 48 states and DC today. And we've reached over 99% of the contraceptive deserts that are in the United States today. We're also one of the few companies in the sexual health and wellness telehealth space to accept Medicaid, and also one of the few to combine telemedicine and a direct consumer pharmacy, along with broad insurance coverage. And we feel those are very strong differentiators from us, from the other competitors in this space. And I wanted to talk to you today a little bit about developer environments. Next slide, please, Elliot. So let's think about why this is important. So anytime that your engineers and developers spend building or rebuilding the environment that they develop their code in is time that they're not spending contributing to your business goals. And this is not an issue when you're a small team, 1 or 2 or 3, but as you bring on more engineers and bring on more folks in the business, it quickly becomes a place where engineers can spend, hours or days setting up their environments, or if they break for some reason, spending that same amount of time rebuilding those environments. So I want to take you through kind of the evolution of how we've thought about this challenge at the Pill Club, starting with just the basics. Next slide, please, Elliot. So we started, like many others did, with a readme.markdown file. And that file contained instructions for setting up all these different things like database tools, local secure SSL certificate setup, a database, a caching layer, ways to fetch secrets that are used in development of the product, and app build processes. This file got to be about, I think, 1,000 lines long before we started looking at things like Bootstrap scripts. This is a script that runs and tries to install those things for you. But there's some downsides to both of these configurations. If you're setting things up via Bootstrap script, you have to take into account all of your developers and all of their OS configurations, any versions of things they might have pre-installed on those machines. And this is a hard task even for companies that ship software to like a regular application developer machine. So it's even harder for us who are in the application development space, where we're used to working with like one version of Linux on a server somewhere that we upgrade occasionally. So the other option for a typical dev environment is to have something like a README file that you set up manually for each developer. And this works, but the developer productivity is delayed, sometimes by multiple days during onboarding, just for setting up the development environment. I've had issues before working with developers on our team where things like the new Mac OS upgrade broke our development setup, and we had to scramble to get that fixed so that folks could do their work. We've had things like MySQL versions change on us and how the passwords are secured. So these are all things that you have to keep in mind when you're developing these kinds of scripts or README files. And on top of that, if you want to have your developer machine accessible by others in the company, whether that's business stakeholders directly, other application developers, management, engineering management, it's a highly difficult challenge to get secure shared access to a developer environment. And what I mean by that is the ability for another person in your team to look at the code that's in development as it's intended to run. So we did this for a while at the Pill Club, and then we started thinking about, what are the solved problems in this space that we can take advantage of? And we looked at Docker. And at the time, Docker was a good way to run your application containers in production and in staging environments, but there are pitfalls when you try to run it on a developer machine. Things like getting access to logs, getting access to files on the system is complicated. And then we looked at something called a dev container. And next slide, please, Elliot. So a dev container environment, let's talk about this. This is like Docker with some additional ease of use features, like the ability for developers to quickly view the logs for a running container, to have a GUI that allows them to access shells inside that container to debug what's happening there. It's set up via either a devcontainer.json file or via another kind of file, depending on which vendor you're using. The advantage of this is that it requires a lot less Docker knowledge for an application developer to operate. Again, there are shortcuts for things like looking at logs, restarting containers, getting a shell into those containers, and it doesn't require you to know all of the Docker CLI commands by heart, like a lot of the DevOps team does. Some advantages here are when things go wrong, you can just throw away that environment and rebuild it. And because it's based on Docker, it's a lot easier to get back to a known good state in your dev environment. And it takes like 5 minutes to rebuild as opposed to a couple days sometimes to figure out what went wrong, how to fix it, where to go from there. And as you can see in the diagrams here, all of these components that would normally be installed directly on the operating system are in containers, either temporary or ephemeral. And one thing that I want to call out here is the local port section on the upper right-hand side. So the dev container environment gives you the ability to have a local port that leads you to the running development application, but that's still very difficult to share. You can do something like open that up to the public network if you really want to. That's not very secure. You can do things like have a forwarded tunnel with SSH, but that becomes very difficult to manage. And so we thought about this challenge a little bit more. Do we really want to be investing time in setting up an environment that works pretty well for an individual developer, but is difficult to share? And that's where we came up with the idea of adding Twingate into the mix here. Next slide, please, Elliot. So this is pretty much the same thing as a dev container environment, but we add a Twingate connector up at the top that runs as an additional container inside the Docker system. And what that allows you to do, because the Twingate container works off of DNS, is that you can assign host names to these different containers. Like, for example, the database container. You can say, hey, this database container is available at this host name. And then your end users, for in the business or other engineering users, can access these running containers from any machine that they have the Twingate client installed on, without any inbound ports open, with access control lists defined by administrators, and some other advantages, like if you feel that you want to shut down one of these environments, you can do so via an admin panel instead of trusting that the environment shut down already. Um, and this made us feel really good about this setup, because it makes the sharing painless. It keeps the control over what's shared in the hands of administrators. And at the same time, it enables folks across the company to access these resources, and really improves the collaborative feel of our development. So that's kind of how we have evolved our dev environments over time. And to be quite honest, this was not as easy or painless a process as it looks via these slides. This has taken us, many months to get to the point where we're comfortable with this solution, and years of development on the part of our open source Docker developers, on the part of folks who develop the IDE tools. And we wanted to take advantage of all that work, especially the work on the Twingate side, that makes this a really great way for developers to build and share their work with others.